joining the league down south. And so our new rival could be Cle Elum because they're close.
They are.
Yeah. Okay, here we go, you guys. I'm going to record this lesson. So question number 1 talks about what a radian is. A radian really is, it's an angle. But the cool part about that particular angle is it equals its arc length. So if I were to draw a picture even, I know that this angle here would equal this arc length here. That these two things are equal if you have an angle in radians. Degrees don't work like that. Okay, number 2, if I want to do conversion, I'm just using my degree over 180 times pi. So 250 over 180 times pi. I reduced it to 25/18 radians, pi radians. B, the problem is you get this minutes. So 24 minutes out of 60. I did that first, and I converted my fraction into a decimal, okay? And that's how I convert the minutes. And then I just used my formula, my degree over 180 times pi. I used a calculator, and I rounded my answer to about 2.35 radians. Okay, number 3, we use the other formula, which is the theta over 180 times your radian. Nope, I got that wrong. My bad. Whoop. It's my 180. I'll put it down here. 180 times my pi times your radian. So I did that. I put my 7 pi 12ths in for my radian. I canceled the pi's. 180 times 7 divided by 12 is about 105 degrees. Okay, D, same formula. Okay, except for it's not going to cancel the pi's at all. So I just used my calculator, 180 times 4.23 times pi, and I got an answer of 242.361. Now, if I need to change that to minutes, I know the answer is 242 degrees, but I'm going to change this decimal into minutes. So I just multiplied that by 60, and I rounded up to about 22 minutes. Okay, let's turn the page. I at least turn my page. Number 4, I just used the unit circle. I need a y value at 5 pi 6, 1/2. Tangent of negative pi thirds is a rotation down here to negative pi thirds. I need my tangent value square root of 3, negative square root of 3. Cosecant is 1 over the y value, so I find 3 pi fourths. 1 of the y value is 1 over square root of 2 over 2, and I flipped it and rationalized it. We did this in class. Okay. Sine inverse, 7. If I want the sine inverse of square root of 2 over 2, I'm looking for a y value. And I'm looking for the angle. I'm looking for the angle. So y value square root of 2 over 2 is here. The angle is pi fourths. Okay. Arctangent, so I'm looking for an angle, but I need the tangent value of negative 1. It's here, and it's here. This one's closer, so it's going to be a, not 7 pi fourths, but a negative pi fourths. Secant is not on the unit circle at all, but cosine is, so I changed it to 1 over cosine. Because it's a fraction, I made negative 2 over 1 a fraction, then I flipped both to make it cosine. Cosine of negative 1/2, I'm looking for an angle, an x value of negative 1/2, it's here. My angle is 2 pi thirds. 10, I'm given the information that I have. Sector is 20, that's K. Central angle of 0.8, I wrote that down. So I like to write down what I know. I want to find R and find S. So I find the easiest or the best formula. So the first formula I found was the sector formula. And it has a K, and it has a theta, and I can find R. So I took half of that. 0.8 is 0.4. I divided by 0.4 to solve. I got 50. Took the square root of 50. I got about 7.07. So that's the radius. I also need to find the arc length. Now I can use this formula because I have the radius. I can use S equals R theta. Easy. 7.07 times 0.8. And I got about a 5.66 centimeters. Okay? All right. Then 11. Now 11's a little bit interesting because when you get this information, you see something like, you're like, what the heck? My mind goes to the unit circle. When I see things like this, my mind goes to the unit circle. Well, pi halves to 3 pi halves. So I need to draw a triangle. I've got to draw a triangle, and the triangle is going to be somewhere either in quadrant 2 or quadrant 3. How do I know? Well, since I'm given the sign as a negative 3/5, it has to be in quadrant 3, because I know sine is y over the r, so my y value is a -3, so it has to be in quadrant 3. So I drew my triangle, okay, and I knew this is my radius, so I drew my triangle, I knew my y value is -3, and my radius was 5, okay, or my hypotenuse. Well, then I needed to find the x value, and I just used Pythagorean's theorem. X squared plus y squared equals r squared. X squared plus 9 equals 25. X squared equals 16. I took the square root of 16. It's either plus or minus 4. Well, which one is it? Well, it's got to be -4, because to graph this, you got to go back 4, then down 3, so it has to be -4. Okay, when I have all that, I have x, I have y, and I have the radius. So then I can find out what these are. Well, cosine is the x over the r. Easy. X over r. Tangent is the y over the x. Easy. Y over the x, which is my -3 over 4 or positive 4. Now there's two ways to do cosecant. One, it's the reciprocal of sine, or you can just go r over y. Gives you 5 over -3. Secant, two ways. It's either r over x or it's the reciprocal of cosine. Either way, you get 5 over -4. And finally, cotangent is either reciprocal of tangent, or you know it's got to be the x over y. Okay? Almost done. Last question talks about this apparent size. So if you imagine in space, here you are on Earth, and you're looking at a planet, and the planet looks really, really itty-bitty, super small when you look at it through your eye, and so that apparent size is the angle. That little size is an angle. Now, if you think about a gigantic circle in space, then what you get is a radius. That's the length from here to here, the radius of the giant circle, and the arc length. Now, the arc length, because it's so big of a circle, is nearly flat, and that can be an approximate for the diameter. Even though there's technically some curvature, it's negligible. Okay, so then you just use your arc length, S equals R, theta. Theta is your apparent size, your angle, and just multiply those two, and you get 8,120 kilometers. Okay, that's all I have. This should be a super easy quiz. At least I hope so. Easy quizzes are always nice to have, aren't they? Yeah, right? That's all I got.